Hello everyone, and welcome to the lecture on the range function. So in this short lecture we'll be discussing the range function, and we haven't developed a very deep level of knowledge on functions yet, but we can understand the basics of this pretty simple function, range. It's going to be extremely useful, and you'll see a lot throughout the code. So here I have the Jupyter notebook open. This is what we're going to be going over. And what's interesting is there's going to be a pretty interesting Python 3 alert that happens, and we'll be exploring what that means later on. So let's go ahead and just get started. Right now I'm working in Python 2, and we're going to use range. So what the range function allows you to do, it allows you to create a list of numbers ranging from a starting point up to an ending point. And then you can also specify step size. So if I just write range and then click Shift Tab, since I'm working in IPython, it's going to go ahead give you the doc string here. So you can say range stop, give a list of integers, range start, stop, step size. So this is basically what we're going to be going over. So I have the range function, and I can give it a starting point and a stopping point. So let's go ahead and run that, and then it outputs a list of integers from that start, up to that stop, but not including it. So if you notice, I have from 0 all the way up to 9, and you can kind of think that this relates up with 0 indexing. A lot of times it's confusing for beginners. They expect to have a 10 in the output list, but remember, it's up to, not including. Okay, so moving along, another thing you can do is just specify for the 0 there by default. So I could also just put 10, or let's say 11, and you can kind of think of this as if you put in range with just a singular number, it's going to give you from 0 up to, but not including that number. Okay, and just to drive the point home that we're outputting a list, I'm going to say a variable x is equal to range from 0 up to 10. And then if I output x, it's going to be a list. And another function we can use to check the type of object it is the type function. And so for the type function, you just put in type, and in parentheses you enter the object, and it outputs the type. So we get a list out. And let's go ahead and just explore this a little further. I'm going to say my start can be, let's say, the number 5. My stop will be the number 20. And I'm going to say, give me range from start to stop. And you'll notice I start at that number 5 and output it, and I go up to, but not including my stop number. Okay, so we notice how I went up to 20, but not actually produced 20. So it goes up to, but not including, just like in an indexing. Something we're going to explore now is step size. So we can specify that as a third argument. So I'm going to go ahead and change my start to 0, so I get the numbers 0 through 19. And then as a third argument here in my range function, I can specify a step size. So here, if I enter the third number to be 2, I'll go in steps of 2. So basically all the even numbers up to, but not including 20. So this is a useful tool later on in your code when you want to produce lists of a certain range or at a certain step size. Range is going to really allow you to do that very quickly. Okay, so that's not it. We'll have a Python 3 alert, so let's go ahead and jump back to the Jupyter notebook. And this is going to be a bit of a sneak peek at introducing generators. Let's go ahead and jump to a quick brief presentation on what is actually going on here. Okay, so we're at the presentation, and we're just going to go over a brief explanation of range and xrange, and Python 2 versus Python 3, and how to deal with these functions. So you might have been wondering, what happens if I want to do a huge range of numbers? So if I said range from 0 to 1 billion, can your computer store that all in memory? And that's a great question. So you can imagine if we had put range 0, a billion, your output is going to have to save every single one of those numbers in a huge list. but maybe you just wanted to do a for loop for each of these numbers and didn't actually need to save the entire result. So that's where generators come in, and we'll have an entire section devoted to generators, but right now I'm just going to give you kind of a sneak preview and a quick explanation of what they are. So you can think of a generator as allowing the generation of these objects, or it's sometimes called generated objects, and they're provided at that instance, but it doesn't store every instance generated into memory. So if you use the generator for creating that, basically that output of numbers, you wouldn't have to store each single one of those numbers. So for instance, if you wanted to get all the numbers from 0 to a billion, use them once, and then toss them aside, that's where a generator could come into play. You wouldn't have to save those billion numbers in a list. So like I was saying, this means a generator is not going to create a list to generate like range does, but instead provide a one-time generation of all the numbers in that range. So specifically for Python 2, Python 2 has a built-in range generator, and it's called xrange. And it's recommended to use xrange for for loops in Python 2. So in Python 2, the normal range function is going to output a list, and it's going to save all those numbers into memory. Xrange will generate elements but not save them into memory. Now, if you're using Python 3, the normal range is already a generator, and you don't need to worry about using xrange. You'll only ever just use range, and that's it. Okay, so let's go ahead and hop back to the code and see some examples of what I'm trying to explain here. So let's go ahead and start off with a simple for loop example. So I'm going to say, let's go ahead and make a list equal to 1, 2, 3, 4, 5. And I'm going to say for num in L, my list, go ahead and print that number, that num. Okay, perfect. Now you remember earlier we set x equal to this output of the range function, and we were able to get a list. So now let's go ahead and do that. So instead of that L, I'm going to go ahead and say range from 1 to up to but not including 6. So I'm saying now for num in that range, remember that outputs a list, go ahead and print that num. Shift enter to run that cell, and you notice it gets the exact same result. And let me go ahead and change that slightly so you can see that it's actually running. Okay, so change that back to 6. So that's an example of just a regular range function in Python 2. Now, something to note is that Python is actually saving this and creating an entire list with these numbers. So what if you wanted to do some gigantic range? You wouldn't want to run this because now you're going to take up a huge amount of memory with that gigantic list. So that's where the xrange comes into play. So if I use xrange, I'm going to generate those numbers but not actually save them. So let's go ahead and see what this looks like. I'm going to go xrange from, let's say, the numbers 1 through 10. I run this, and you'll notice the output is really similar. It's the same almost, just the fact that the range is different. So let's go ahead and go back to 6. And you'll notice as far as this for loop's concerned, nothing's really changed. But now let's go ahead and just look at what's going on if I were to type xrange 1 through 6 by itself. Notice my output is just xrange. And let's go ahead and check the type of that. So I'm going to say x is equal to the xrange 1 to 6. And if I ask for the type, you'll notice now the type is xrange. It's actually a generator now. And if I were to set, let's say, x2 as range 1 to 6, and I check the type of x2, that's actually a list. So the main takeaway here is that for Python 2, if you're using range in the fashion of a for loop and you actually don't need to save that entire list, go ahead and make sure you use xrange to not have to waste memory. For really small, let's say like anywhere in the thousands or tens of thousands, that's not going to be a big deal, especially with how much RAM computers have these days. But it's good practice to use xrange and to know what's going on when you're reading someone else's code. Now if you're using Python 3, Basically, you don't have to worry about this anymore, and range is the X range. Okay, so one last thing. Remember, X was X range type. So what would happen if we tried to cast this as a list using the list function? Then we have the output that we would have gotten from range. So we can actually confirm this by checking that x2 is equal to this x range casted into a list. Okay, so I know this was a little advanced, but don't worry, we're going to go over iteration and generation in much more detail, but I just wanted you to be aware of essentially this Python 3 alert, where there's a difference between range and x range in Python 2, but in Python 3, this range function has become that generator, and it's not going to save that entire list into memory. And if you wanted to save that entire list into memory, you'd have to cast it using something that looks like this list. Okay, so that's it for range. Just a quick overview. If you ever find yourself trying to make a list of integers in some sort of sequence, keep in mind range and x range are good options there, and you'll see them a ton in your code and in other people's code. Alright, that's it for this lesson, and I'll see you at the next lecture.